Now let's illustrate some facts we just derived about a simple pendulum. So a simple pendulum is anything, any mass that's placed on a string or wire, whatever, and can oscillate back and forth in simple harmonic motion. And we learned that the equations that we derive for a mass on a spring are the exact same equations that govern the motion of the mass at the end of a pendulum. Okay? Now, one thing that we learned, though, is that the period there is 2 pi times the square root of the length of the pendulum divided by g, the acceleration due to gravity. Where here on the Earth, it's 9.8 meters per second squared for g. So, any pendulum of the same length L should have exactly the same period, no matter the mass of the bob that you're using on it. So here's an example here. Here I have something that's kind of like a billiard ball in weight, pretty heavy, compared to this really light wiffle ball, okay? But they have the same length of the pendulum. So our derivation equations tells us that they ought to have the same period. Okay, so let's check it out. We'll displace them by roughly the same amount and let them go. And indeed, they have the same period. Pretty cool. For practical purposes, you might have already noticed this. If you ever take your younger niece or nephew to the playground and you're both on the swings, you have a big mass, but your 4-year-old niece or nephew has a much less mass than you, but you both swing at the same rate. And the reason is because the length of the chain of the string is the same. Now, if you put your niece or nephew into the baby swing, which has a shorter length, then the period, in fact, will change. So let's do that. Let me change the length of the period here by pulling up the string, and I'll try to get it a factor of 2 in difference there. Get this out of the way. All right, so let's see, displaced by sort of the same angular amount, and you can see that the shorter pendulum has a much shorter period now. It goes back and forth much faster than the other one. All right, so that illustrates our pendulum there. One real life example too, if you're ever walking around campus with your friend, if you are a 6 foot tall person and you have very long arms, your arms will naturally move back and forth at a different rate than your friend who is shorter and has shorter arms. Check that out next time you're walking to class. Okay.